Hello, everyone, and welcome. I'm Rachel Kemp from the Product Marketing Department at Azion, and it's great to see everybody here and to host this webinar. Before I get started, just a few words about the webinar. Managing the impact of critical vulnerabilities in your application is always key to keeping your data secure, but it can be a really complex task with all the third-party code used in applications today. So we're going to learn a little more today about the web application software supply chain, some of the risks that using those third-party components can present, and what you can do to reduce those risks. But first, I'll quickly review the agenda for today's presentation. So we'll start with a brief introduction and then discuss the security challenges of the software supply chain and how to lower the risk in your web applications, followed by a demo of blocking the critical log4shell exploit. After that, we'll have a Q&A session with our speakers, so be sure to submit your questions via the Q&A button, which you can do at any time. This presentation is being recorded, and you'll all receive a replay link after the conclusion of this webinar. And before we get into our talk, let me tell you just a little bit about Azion Technologies. Azion is an edge compute platform that simplifies how you build and run modern applications anywhere. Azion has over 100 edge locations worldwide, delivering apps and content with super low latency, with security that's built in from the ground up, and the ability to take advantage of serverless functions at scale. And now I'll turn it over to our speakers to introduce themselves. Mauricio, we'll start with you.
Okay, thanks, Rachel, and thanks for the intro. Appreciate it, and thanks and welcome for everyone that's here for this webinar, and we're looking forward to share and have a discussion with you all. Thanks for the participation. So I'm Mauricio, I'm a CISO for Azion, and I have over 25 years of experience in the security market, working in many areas, as an auditor, as a security officer, and many other positions. So glad to be here. So I'll pass to Andrew to introduce himself.
Thanks, Mauricio. Hello, everyone. I'm Andrew Johnson. I'm a senior product marketing manager here at Azion. Over the last 5 years, I've spent time in application security and endpoint security, both in product marketing and also product management. And I'll turn it over to Cassio.
Thanks, Andrew. Hi, my name is Cassio. I have spent more than 20 years of experience with open source and security standards across multiple sectors, from government to multinational corporations, and now at Azion Security Team as security specialist. Thanks. Can proceed.
All right, great. So with no further ado, I'll have Andrew kick things off.
Thanks, Rachel. I'll start today's conversation by talking a little bit about the web application development landscape today, including its software supply chain, as well as some of the security challenges that arise from it. But first, why are we talking about web applications? Well, for many companies, web apps are the most important connections to their customers, employees, and other major stakeholders. Thus, web apps are rightfully the focus of their innovation efforts as they strive to consistently push out new features and products to enhance the digital experience. The evolution of software development practices like DevOps, the increased adoption of APIs and microservices architectures, and all kinds of innovations in dev and infrastructure tools have made it possible to ship code faster than ever before. And just how fast are companies moving these days? One study by Puppet found that middle tier DevOps teams are releasing daily to weekly. And a study by Google found that elite DevOps teams have the ability to release new code multiple times per day. And the reality is that a big part of most shipped software includes code that you didn't write. That's a way companies can be more efficient, move quicker, and that's definitely not something that's recent. Java, which is one of the most popular frameworks to date, debuted in the mid-90s. And the code that's in most of commercial applications, it's third party today. That's considered the supply chain. You can see a couple stats on the right. Veracode found that about 70% of commercial code is open source. Another firm, Contrast Security, found that the average application contains around 118 open source libraries. And Veracode found that the typical Java app is made up of 97% of open source libraries. And leveraging third-party code is not a bad thing. As I mentioned, it increases your efficiency, allows you to move faster, allows your company to concentrate on writing higher value code. And honestly, it's generally these third-party, this code is generally more secure than in-house or custom code. But what's the problem? Well, libraries and frameworks become outdated. According to research, the average library uses a version that's about 2.6 years old, and it's not really too surprising when you think about it. Engineers like to use what they know. Refactoring or upgrading components usually has a pretty high cost, and we know that no code is perfect. Even though I said it's usually safer than in-house code at first, from time to time, the community, researchers, white hat or gray hat hackers or otherwise will discover vulnerabilities in widely used libraries. And that's a problem. So much so that the OWASP Foundation ranked outdated and vulnerable components as number 6 in their top 10 list. And despite the best efforts of dev and security teams, the code used in web apps remains far too vulnerable. Contrast Security found that there's around 50 vulnerabilities in the open source packages or libraries used in the average Java app. Veracode, which is another firm that does a lot of software composition analysis and scanning tools, they found, and they see a lot of applications out there, they found that about 66% of apps out there contain an OWASP top 10 flaw. And they also found that flaws remain unfixed in third-party libraries for, 77% of flaws found in third-party libraries remain unfixed for over 3 months. And that's sounds like a lot, and it is. It's a pretty big window for attackers that know about a flaw, know how to exploit it, and are constantly scanning, websites and applications of companies out there all the time. Kind of on the left, you'll see some notable software packages or frameworks that had severe vulnerabilities exposed over the last couple of years. Spring4j, Log4j, Apache Struts. These are pretty severe. There were some pretty severe vulnerabilities discovered in these libraries. In all 3 of those I just mentioned, remote code execution could be the outcome of exploitation, and that's that gives hackers the ability to run arbitrary code on the server and get to the data behind those applications. On the right, you can kind of you might have seen some of these names in the news over the last few years, unfortunately for a breach in their web application. I'll just mention that the Verizon data breach investigation report found that 39% of breaches it analyzed over the past year originated in web applications. So that it's really still a big problem today. And so now we've talked about the problem, and I'll turn it over to Mauricio to talk about what you can do to lower your risk.
Okay, thanks, Andrew. Thanks for the background and information that kind of illustrates what's happening and what we see on when you talk about web application security supply chain, particularly for third-party parts of the software that you develop. And now we're going to discuss a little bit on 3 items that 3 practices or items or process that might help that can help and will help the lowering our risk when we are dealing with the software development and web application development life cycle. So in this are three parts of a larger processes that larger practices that we need to implement in our companies, right? So but these are really fundamentals that they are not new to information security, but are fundamentals that if we execute them right, we're going to lower the risk as we develop web applications in our companies. Let's move over to the next slide, Andrew, please. So the first thing that we, it's a very fundamental concept, fundamental practice that we need to adopt. And it's, as I said, not new. It's something that's here for 10, 20 years or more than that, right? So, but it's the concept of secure development. And now on the literature, what you're going to find a lot is the S-SDLC, or the Secure Software Development Lifecycle. And independent of the type of development that a company runs, agile, the old waterfall, extreme programming, whatever is the process and the methodology to develop software, the SDLC, it's kind of a meta layer or a layer on top of that saying, okay, to develop securely, this is what we need to do. So, and then everything, as many things in security, we start assessing the risk. So when we think on developing a web application, we're gonna need to understand what problem and what risk we're gonna mitigate, what business we're gonna attend, what business needs we're gonna attend for that development. And knowing that, we're gonna know the risks. The next part that needs to think on S-SDLC is the design. So we need to basically design, draw the application, where are the application boundaries, where the data goes in and out the application, sorry, or even in and out modules of the same application. And then we need to review the design. We need to take a step back, look at the threat modeling, say, hey, okay, now we are comfortable. We see where the data is going to flow and how the data is going to flow in this application. And here are the controls that you need to implement. After that, next step is the development, right? And on the development, where many are going to be using agile, extreme programming, C#, whatever makes part of the package of development for the development team, we need to implement security aspects on that development. One of them, very known, is the static code analysis. And this is automated. This is most or majority of the modern tools for static code analysis can be integrated with the pipelines, with the CI/CD pipeline for development, and give like almost real-time view for the developers of the problems that a code might have. After we develop that, we move downstream in the environment, downstream now in our pipeline, we're going to test, right? And along with the regular Q&A test, right, the quality analysis test, or quality assurance test for that we have to make sure that the applications attend in the business and respond to the risks. We also should aggregate security tests there. Some unity pen test or something that gives us a view that the static code analysis cannot give us. And here comes other tools that can be integrated with dynamic code review. And then after we move down the line, in our pipeline, we are ready to deploy, and we deploy in, let's say, a pre-production environment. We can execute pen testing, and we can ensure that the configuration is secure. And then after that, go to production and deliver the application. And even that, when the post-deployment, we need to continue with pen testing and continue ensuring that the security is configured correctly in the application. So, and this is, in a nutshell, the S-SDLC, right? Let's go on to the next slide, please. So, and here's just a kind of pipeline view on how we can integrate. Another way that we can see the secure development lifecycle, or the secure system development lifecycle. So we think on architecture where we consider all items to make in architecture-wise to make that code and that web application correct. We think on as we are architecturing, or if you think on the cycle from the previous slide, on when you're planning, we think on what kind of third-party software, what kind of libraries we're going to use. As you saw on a slide previously that Andrew presented, 70%, if I'm not mistaken, that was a number, of the code in our application today is made out of third-party software, meaning software that we not developed. And for web applications, this is particularly true because you're going to have Node.js, you're going to have Log4j, whatever you need to maintain that application, and the code that we make, it's might be very minimal in comparison to the code that comes from the third-party libraries. So on the architecture part and on the design part, you need to think which is the software they're going to use and how critical this software is. And code review is, and that part, and this can be considered not only the development part, but how we make sure that we are using the best practice to code and how the developers know that. Down the line, we're also going to need to think about the tool set we're going to use, which tool set we need in each part of that cycle. And in the end, how can we use pen tests? And as I said on the previous slide, we can use pen tests in at least in two parts of the S-SDLC cycle. So one before deploy and after the deploy. Next up, please. So some more benefits of the S-SDLC is, in the end, if we start thinking security from the beginning, we're gonna have our software more secure and better at the end. And also gonna reduce cost of fixing vulnerabilities if we fix them in the beginning. The S-SDLC also have a component of communication. So if we run the S-SDLC as specified, we also going to have all stakeholders and all people involved knowing the risks and knowing what we are executing in each phase. And in the end, with a software that was planned and thought security since the beginning, that all stakeholders were involved and communicated, in the end, we're going to have something that reduce the risk for the business. Next up, please, Andrew. So the second, let me just take a water here. As a second fundamental that I would like to bring here to you guys is a patch management program. And this is particularly important when we are talking and are thinking on the web application supply chain, and we are thinking and talking on third-party software. So we can patch anything, right? So we patch our code that we develop, but it's very common to think and move a patch management program thinking on the third-party software that we run in our web application, the software infrastructure that maintain the application, and even at the server level here. Okay, so a patch management needs to encompass everything, but bringing to the web application topic here, what you need to think on the patch management program. We need to have the inventory of what software we're using in our application. We need to maintain that inventory, and we need to execute the cycle of the patching in a way that reduces the risk and reduce the vulnerability that third-party software and including our own software creates in the environment, right? So a few things that the patch management program must take care of. The removal of all unused dependencies and features and components that we don't use anymore. Continuously make an inventory of the components that we are using in our web application. They can be like client-side items, server-side items, libraries, whatever they are, right? and verify the quality of the components of what's being used, the source of the third-party software that are using. And also, as part of the patch management program, we need to monitor in the end if this patching program is working right. Next up, Andrew, please. So in the end, with having a patch management program that's going to run every 30 days, every 60 days, every 90 days, every week, whatever makes sense for the company, you're going to have a more secure environment. We're going to adhere to compliance standards like PCI, for example, that demands that critical and high vulnerabilities are fixed in less than 30 days, right? And this might vary depending on the standard that we are looking for, right? So, and even PCI, I think it's lowering those days to much less than 30 days. And if we are adherent to compliance and standards, if you have a more secure environment, any regulatory baselines that we have on our business also gonna be mitigated because we can avoid penalties and fines and so on. Okay. Now for the third part of, or the third fundamental that I'd like to bring on. So, and as a fundamental, the fundamental here is protect the border. So that's not the title they are seeing here because you're talking about a web application and web application supply chain, right? So if you think traditionally in security or in a traditional, let's say, implementation of any corporation, right? Our borders, we usually think on networks, right? But now with that, we have a lot of cloud presence, edge presence. We have a lot of SaaS and other environments where they are not exactly all in the same place. The borders are wherever those applications are. That's to say that a company today that develop a solution based in cloud, AWS or Azure or any other solution, the border is not on premises for that company anymore. The border now is on Azure. That border is now in AWS. That border now is on the edge server from Amazon, for example. So the concept here behind the use web application firewall is use something to protect your border. And when you think on web application, we must think on a web application firewall. Let's move on, Andrew, please. Just one step back to recover the concept of web application firewall, right? So the concept in web application firewalls, they are in the market for 20 years or more, right? So in 2000, 2002, and so there are already solutions of WAFs for being like appliances to be installed in a data center, to be installed on premise. Now, on these days, we have WAFs and web application firewalls as services, right? We have web application firewalls that they don't run on your premise anymore. They run on the internet, but they work and they function as WAFs. So with that in mind, you need to think that, and this is, sorry, let me take a bit back. That says that we have much more flexibility now, meaning we don't need to have a data center. We don't need to have a box that are going to be installed somewhere, but you can hire service. You can get a service from a company that provides WAF and protect our application. So this gives much more flexibility and agility to deploy and use WAF. So then, as a good practice, we developed well, we patch well, now we protect our application well using a WAF. So, and what WAFs do? They basically stop attacks before they reach the application. They can detect malicious code and malicious attempts before it reaches the application. In legacy systems where we have applications that we cannot improve or cannot upgrade, we can put those applications behind a WAF that are going to filter some injections or cross-site scripting attacks, whatever that legacy application might subject of. And we have more times to change the application or fix the bugs on that application. We can have more or faster feature release to production, meaning while the WAF is protecting the application, we can use more cycles to deploy other features that are not exactly security to production and maybe make the business deliver more benefit for the business, right? And also we can reduce our worries with third-party application or legacy code. Okay, next step, Andrew, please. And a few more benefits of WAF or thoughts about WAF is usually WAFs are used setup. Most of the SaaS solutions or the solutions that we see on the market today, they come pre-configured, right? So you can just, in majority of the 8 types of attacks, or at least the WASP top 10, they're going to be blocked because that's a standard configuration for a WAF. So it's fast to deploy, easy to set up. And on WAF as a service, right? So it gives, usually you don't need to maintain that. You are hiring the service, and some part of that is maintained by the solution that you are hiring, right? And also helps to keep on compliance, right? So for example, a company that needs to deal with credit card information, to stay compliant and use WAF should have a vendor that's also compliant with PCI, right? So in that sense, it helps to keep the compliance as well. And in case of PCI, just to close that, it's kind of mandatory, right? So, okay. So just to recap how we lower the risk on the web application supply chain. One, we develop securely, right? We have standards, we have a process, we verify our code, we pen test our code, and we maintain that in production securely. We update the basic software, the libraries and the OS, and we protect the border. In the case of web application, we protect the border with web application firewalls. So, and that kind of closes the idea here of how we lower the risk on the web application supply chain, developed supply chain. And now we're going to go move forward and show you guys a little bit of a demo of, I think you can go to the next slide, yeah. A little bit of a demo how a WAF, a standard WAF application can be protected against Log4Shell, right? So we're going to show, Cassie's going to show you the demo here where we have a scenario where, and this is in our own lab here at ASIAN, we had a scenario where the application was subject for Log4Shell attack. And we're going to show before and after that application goes behind the web application firewall. Okay, thanks, Cassio. Take it over here.
Thanks, Mauricio. So there is an expressive number of known attacks that can be explored by malicious people nowadays, and commonly new attacks every day in a short time are available. This is why they are still relevant as an application security and code protection, because they are still happening in well-known companies without any security-related tooling. So can you go to the next slide? Thanks. And like as Log4Shell discussed during this demo, but there are also other well-known similar exploits like Spring4Shell, Apache, common vulnerabilities, and so on, not discussed today, besides Log4Shell in this case. But Log4Shell is still zero-day and widely exploited in big companies without any WAF implemented. So let's start with the demo, which consists in 2 steps. First, the attack succeeding without WAF enabled, and afterwards, the attack blocked by WAF itself. So we can start the video demo. And this is the vulnerable application code found in Python from GitHub public repository, which explores the Log4Shell vulnerability and how to gain remote shell execution from the code vulnerabilities found, and in this case, from the particular LDAP vulnerability. So in the left side, we have the Java Web Demo website application with user and password login form within, and this is the login process, which is the surface attack we are exploiting. And in the right side, we have 3 terminals. The top terminal is one of the command prompt to start the web application and demo, as I'm doing it right now and already started. The middle terminal is where we can see some server logs, as well confirming the LDAP exploit output error from the server itself, and where we are able to confirm the attack succeeds before the WAF enabled in the OS level. And the bottom terminal is one of the most important ones, which will output the web server application logs, confirming the client-side access remotely. As you can see, if I refresh the browser, it will add new lines in the web server log files in the bottom terminal each time the client side reaches the server side as expected. So let's try to force the login with the known LDAP exploit and showing in the middle terminal some log outputs, but also in the server side from the bottom terminal, that nothing will happen. Confirming in the middle terminal with some logs from the exploit was executed and some shell or sh binary were executed remotely multiple times within the server itself in the top terminal. As you can see now, I'm running some commands. And this is the OS level, okay? So we can start with the second part of this session about how to secure your web application with Azion's WAF. After login to the Azio's RTM with the WAF application already configured in this case, first let's check the Edge firewall configuration setting and confirm the new WAF configuration is enabled and the correct domain chosen. Let's save it. Afterwards, we need a couple of seconds in order to propagate the configuration settings before we go to the WAF rules in the top menu below. And this is the right place to set up the desired filters and check the logs from attack activities and their number stats. So let's enable it. There are some other settings we can do from time range to network, but let's apply the standard filter and see the results. So let's check it out. In these settings, we need to enable the WAF filter in order to stop the attack, and then let's repeat the same attack executed previously. So as you can see, which confirms the attack did not succeed at all because it was blocked from WAF as planned, and after this filter was enabled, showing the 400 common error. Now you will see how WAF logs the attack and their stats in the tuning tab. And from this session about online application security solution perspective, which needs some time to be updated accordingly and to be fixed from new vulnerabilities, this is why the reason we are using the Web Application Firewall, also known as Azion's WAF solution, is a good idea for this type of security application. Thanks for your time. You can proceed.
Great. Thanks so much for that great demo, Cassio. So that concludes the presentation part of this webinar. We'll now have a brief Q&A with the speakers. So please submit your questions via the Q&A button if you haven't already done so. So I'll start with a question following that demo. It's for those customers who have a WAF already, how would they know if it is actually protecting them against Log4Shell?
Yeah, I can go ahead and take that one, Rachel. So to know that you're protected, let's say you have a WAF from a managed vendor, you know, to know that you've been protected against Log4Shell attack, a couple ways. First, I would check with the vendor, you know, in the release notes, or they might have issued a blog, pretty quickly because it was such a major or critical exploit that was found. So check to see if they're protecting you already, whether you can write a simple rule in the WAF to protect. But then also you might verify. You look in your, maybe the console, as Casio did, to see that the attack was blocked. You can look in your SIM, look at the logs to see that the attack was blocked. You can contact your customer success manager at your WAF vendor, and they'll definitely confirm for you whether you're protected, and you can go through the WAF settings to just make sure that everything's on. But those are kind of high-level steps I would look at.
Great. And then we've got another question on the Q&A about Log4Shell. This is someone who's not familiar previously with the Log4Shell vulnerability, wanting to know, how bad is it, and why haven't they heard of any breaches so far?
Okay, thanks, Rachel. I can take that one. So, how bad it is? Log4Shell is a remote code execution attack, right? And that per se is already a big problem, right? The second thing that makes Log4Shell so worrying is because it does not demand any authenticated user. As we said, as we saw in the demo there, most applications that are subject to Log4Shell, you can run the malicious URL, the malicious request in any login screen, in any login field, or even if you want, like, if the attackers automate that, even through a post of using any mechanism that can do a post to a web server that has log4j enabled in the Apache environment, right? So because of those two things, right, it's a remote code execution and no authentication needed, gives a CVSS score of 10 to the Log4Shell, and this is very critical, right? So that's how bad it is. So any web server that runs log4j and it's facing internet is going to be subject to that attack, either through a post or through whatever forms that might be open on that web application, right? So, and the fact that we haven't heard about any breaches or large problems because of log4j does not mean that they don't exist, right? So they might not have been publicized yet, right? So, and maybe something is going to come up. Some breaches take over more than 1 year to see the light of the day, right? So, but I think issues happen, exploitations happen, in some cases, well, unfortunately, even unnoticed by the whoever owns that server or our application, right? And maybe the attackers they executed, they are in networks or companies that don't even know that the attackers are there, right? So so this is something that I'm pretty sure issues happen. I mean, we just probably don't have all visibility that we could, right? So
Great. Thanks, Mauricio. And now we've got a more basic question about WAF. This person wanted to know, what are some of the considerations that I should think about when choosing a WAF?
Yeah, let me go ahead and try to answer that one. There's definitely a lot of different considerations based on your specific use case of your organization. But a couple that I would think about would be these days, your apps are probably located everywhere, right? Not just in a data center, behind a corporate perimeter. So when choosing a WAF, I would look for a vendor that has a lot of locations, either called points of presence or edge nodes. I would look for a vendor that's highly distributed. And the reason being, you want to cut down on latency. You don't want your end users' requests routed long distances and degrading performance. So I'd look for a lot of presence worldwide or in the regions that you want to focus in. I'd also look for vendors that are, however their WAF makes their decisions. I would choose vendors that have the trust of large brands, with real high value applications or websites. And then lastly, I would look for a vendor that also combines and integrates a WAF with DDoS protection or bot management. These are also kind of like the prevailing attacks on web applications today, so much so that Gartner calls their magic quadrant the web application and API security. And it includes like API security, your basic WAFs or traditional WAFs, but also bot management and DDoS. So having it all in one package, also deployed in the same location, makes a lot of sense, right? Like you don't want, extra hops to, go to stop the bots and things like that. Having it all in each node or point of presence is really key for performance.
Great. So that concludes the questions that are in the queue, but if you have any additional questions that you want to ask us, please feel free to reach out on our social media channels. We want to thank everyone who joined the webinar today, as well as the speakers, Andrew, Mauricio, and Cassio. I hope you found their presentation just as interesting and informative as I did. After you leave today, you'll receive a satisfaction survey by email. The URL is also available on the chat. So please be sure to fill it out and share your opinions with us. It'll really help us out in creating more engaging events and content like this one. And for anyone who might be interested in trying out Azion's security products or Edge platform for yourself, it's super easy to get started. Just click the link in the chat to sign up. It's free to start, and new customers will receive a $300 credit that's good for 1 year and can be used on any Azion services. So thanks again, everyone, and have a great rest of your day.
Thanks, everyone.
Thanks, everyone.
Bye.
Everyone, bye-bye.